Excellent. Algebra, we are going back to PO6 and covering the word problems. Because like we've talked about in CO4, word problems are inherently difficult because you have to translate the verbal to the numerical. You have to make sure you know what's being asked of you. You have to make sure that you know how to set up the required information in order to solve it. And so most equations that we're going to be looking at contain three things: a variable, a coefficient, and a constant. Okay? And so who can define for me? We've done this before. What is a variable? What is a variable? Great stuff. We're going to learn something new today. Mia.
Missing number.
It's a missing value. It's an unknown value, usually represented by a letter. And oftentimes, and you probably have seen this in science before, a variable is used to test something. Can you hear me? Hold on. Gotta pause the. Always in trouble. Okay. So variable is an unknown value. You probably have seen this in working with variables in science before. It's what you're testing, right? When you are doing an experiment in science, oftentimes you are changing something. If you did the whole bean plant experiment in kindergarten or first grade, did you ever do that? You know, where they plant 4 bean seeds and see which one grows the tallest, and you're changing what type of soil you might be using, what type of light it receives, or whatever. Can you put that chair so it's not going to topple over?
Oh.
Thanks. And so the variable is what is being tested. So in the questions below, where you see like, how much money will you have given after 6 months, 8 months, 2 years? That's what's changing. That's a hint that that's what your variable is, or where to find it. Okay, it's what's being tested, the unknown value. The coefficient. Any idea what the coefficient is? I'll give you a button, not the MCU. Nolan?
Is something like that's similar?
Similar.
Answer?
Not quite.
What?
The rule of a coefficient, it's that number that's before the variable. Okay? Girls,
Sorry.
We've reached the end. The end of the line has been achieved. It is the number before a variable. And its role is it tells you how many of the variable you have. How many of the variable you have. Okay? And we'll get back to that in a little bit once we start to write these equations, and we can see exactly what that coefficient looks like. But it's the number before a variable and how many of the variable you have. Then the constant is that initial or starting value. It's what you start with. I would say starting. Actually, I'm going to use the word initial, because that'll come up again later on. Initial or beginning value. It's what you start with. It does not change. Does not change. The definition of constant. Okay? It is continuous. It is unchanging. In this case, mathematically, it's also considered the initial value. So, you sign up to help a charity with preserving the rainforest. That's noble of you. They ask for $20 up front, and then you will give $2 per month. Write the equation. How much money will you have given after 6 months, 8 months, and 2 years? Okay? We're going to identify what is our variable, what is our coefficient, what is our constant. Who thinks they can identify what one of those items is? Nolan.
Oh, I think the variable is how much money will be given after 6 months.
So that's what our equation is going to tell us. Our equation will tell us how much we've given after 6 months, after 8 months, after 2 years, but the variable is how long we're giving money to the charity. Right? The longer we're a part of the charity, the more money that we'll give. Okay? But again, like I said earlier, the variable is what changes. What's changing here is the length of time that we're a part of this. Okay? So our variable is going to be months. So you can use M if you want, or you can stick with N to be consistent. Okay? But the variable is how long we're a part of this charity. All right. Who else has an idea of what the coefficient or the constant is going to be? Let you think about it while I write it here. Coefficient, constant. What do you think? Nolan again.
Oh, is the constant $20?
The constant's 20, and why is the constant 20? Why did you decide on that?
Because it doesn't change.
Right, it's also what you start with, right?
Yep.
Whether you're giving the charity for 1 month or 60 years, you're still paying $20 that first time. So that doesn't change. It's your initial or beginning value.
Create a button for that.
Oh, okay. But he also kind of did because I pushed it. Josie, the coefficient is 2, right? Because that coefficient, it's what we're going to be multiplying by the variable. That word per, if you remember us talking about that last year, it means that you multiply. And it's how much you are giving per month, right? So put it all together, and the amount of money that we're giving to the charity is $2 per month. Right? So however long we're part of this, we're multiplying that length of time by 2, because it's $2 per month, plus the initial $20. Okay? And the result of this expression is going to be how much money we are giving to the charity overall. Right? So now we get to the questions. We can make a function table for this. Last year, they were XY tables. This year, they can be months and dollars, an MD table, okay? But after 6 months, if M is 6, we're going to plug in 6 for M, right? We're testing this now. How much money will we give after 6 months? What's 2 times 6 plus 20? Quick maths. 32. So in 6 months, we've given $32 to the charity. Then it says, well, how about after 8 months, right? So what's changing? Our variable's changing, right? We're testing this here. After 8 months, 2 times 8 plus 20. How much money have we given to the charity? Josie again. 36. Okay? After 8 months, we've given 36. Now, what number are we going to plug into the equation for the last one to figure out how much money we've given after 2 years? Josie? 24. Why 24? Exactly, right? Whatever unit our variable is in this case months, we have to make sure that whatever we plug in there is going to match that unit. I can't plug in 2 for 2 years, because if I plug in 2 for M, that's talking about 2 months. So Josie's saying we have to figure out, well, how many months is this? 2 years, 12 months per year, that's 24 months. And so in our equation for the last one, 24, it's going to be 2 times 24 plus 20, and that gives you $68 an hour. Okay? Good job, Rosie. Right? See how this all kind of connects? Building these equations, okay? Before we can answer these questions here, we have to know, well, what do we plug those values into, right? And that's writing the expression itself. The next one, and I'll scroll down for this. Anybody still writing the notes here? Okay. The next one says, Ms. Schultz has 3,039,001 hairs on his head, and each day I lose 60 of them. Write the equation. How many hairs will I have left after 120 days, 1,580 days, or how about 50,650 days? Woo. Okay. Well, let's start. First of all, what is our variable? And then what is our coefficient? And what is our constant? What can you put up there? William.
Is the variable days?
The variable is days. Fantastic. Some might even say that is, okay? And it's days because that's what we're testing, right? 120 days, 1,580 days, 50,000 days, right? That's what's being tested. Good. What else? Landon.
Constant 60.
The constant is not going to be 60. The coefficient is going to be 60 because that tells us what happens per day or each day. Okay? So the coefficient here is going to be 60. What I start with, that's going to be the constant. Okay? Yes, my total number of hairs changes, but what I start with doesn't. So my initial value, my beginning value, that's going to be 3,039,001. Right? But I do want to go back to that 60 for just a bit. Right now I've got it written as positive 60, but in my expression, it's actually going to have to be a negative 60. Why is that? Why is that, Tristan?
Because you're losing 60 of them every day.
Because I'm losing the hairs every day, right? We didn't put the word lose on our chart for subtraction, but if you lose something, right, you're losing it. It's gone. Subtraction. So when I write my equation, I can say I start with 3,039,001 and I lose 60 hairs every day. Okay? 3,039,001 minus 60D. See how we got that? Does that make sense to everybody?
Yeah.
Why it's subtraction? Why? Okay. And so now, answering the question, we can make a days and hairs chart, right? After 120 days, 3,039,001 is what I start with, minus 60 times 120, because that's how many days that we're testing here. How many hairs do I have left? Not so quick math. Let's go with a calculator. 3,039,001 minus 60 times 120. Yeah. 3031801. 3,031,801 hairs. That's still a full head. I like that. It's good. How about after 1,580 days? Again, and notice, what isn't changing? That 3,039,001. That's my initial data. That doesn't change no matter how many times I want to test different day lengths. 3,039,001 minus 60 times 1,580. Again, not so quick maths, but what do you come up with? Our official calculator. Josie. 2,124,201. Oh, 2,900,000. Oh, wow, what did I hear? All my hairs get in my ears. Can't hear right. Was it 944,201? Okay, 2,944,201. Then 50,650 days. So 3,039,001 minus 60 times 50,650. How many hairs are left? Josie. One hair. And my plan is that one hair is going to be super, super long. So I just wrap it around a bunch of times. And it looks like I have a full head of hair. But yeah, one hair left in 50,000 days. Okay? But that's how expressions work. That's why algebra matters. So that we can predict, when should I get a wig? Probably somewhere around 30,000 or so, right? It helps us predict things that are going to happen in the future by writing expressions, testing variables, doing all those sorts of things. Okay? How does a cell phone company know when they're going to have to build a new tower? Right? Because they're projecting, we've got this many users, this much data is being used, it's increasing at this rate. In 5 years, we'll need another tower. Okay? If they wait until it just happens, well, then it's sometimes too late, right? Then service will get really, really bad. They'll lose customers. They always want to stay ahead. Okay, predictions, stuff like this is huge in a lot of companies. You want to anticipate and react to potential problematic situations before they happen, right?
Yeah.
I can tell you at St. Vincent here, when this place first opened, they already had a maintenance plan for when their brand new things would need to be replaced before they become a problem, right? And you can kind of plan it out a little bit, okay? That's algebra. That's why it matters. Nolan.
They do want them back for them to see.
Did you listen to anything that I just said, Nolan?
Oh, it's something about the school. They had a maintenance plan.
That came from the soul. The soul. Not just my heart.
Sold, like
The soul. No, not the movie.
Oh, okay. Are you never sold?
There are a few things I actually prepare for in a day, like a few things I actually plan. That speech is one of the things I actually plan. Like, I rehearse it.
Like for
You rehearsed that.
Yes, several times in front of
It was really well. So
Did it not give you goosebumps? Did you not feel the emotions?
I didn't feel
I really felt the emotions.
I mean,
the
I
emotions
wouldn't-
were racing through my body. I could feel the emotion.
Yeah, that's what I'm going for here.
Yeah, it was really good.
Nolan just wants
I'm not
to
the No.
Any other questions on this before we move on? Okay. The two on the back, way at the bottom, you are going to do yourself. So we'll go over answers tomorrow. It is going to be homework, only two of them. If we don't play the number game tomorrow, folks, colossal failure here. 2 questions, 5 minutes to work on it. We can do this. I believe in you. The first one says you are just starting to collect baseball cards and already have 30 that you got from your parents. You go to a trading store with 3 of your friends with the agreement that however many cards the group gets, you will divide them evenly among the 4 of you. That word divide turns out to be pretty important. How many cards will be in your collection if the group gets 40 cards, 96 cards, 224 cards? Okay. Hey, look, I'm going to get you started here, okay? First of all, what is your variable? What are you solving for? What's being tested? Zoe, the number of cards in your collection. Okay, so if you want to use C for cards, great, or just N to keep it consistent, fine also. Okay, and I'm going to start with the constant next because the coefficient in this one is actually potentially kind of tricky. But what is the constant here? What's your initial starting value? Dominic? 30. Right, because you got them from your parents. Okay, you can go and buy as many cards as you want to at the store. That's not going to change what your parents gave you. Okay, so the constant is going to be 30, and the coefficient here, because it's division. Remember, you can write division as multiplication. So when you buy these cards from the store, how are you going to divide them among the 4 of you? What operation would be taking a number of cards and dividing it among 4 people? What's that going to look like? I'll give you a big hint. It says divide. Mia.
Divide
by what? There are 4 of you there. You're dividing them evenly. What will you divide by?
4.
By 4, right? There are 4 of you. So a coefficient, we said it's what is being multiplied by the variable. But remember, you can write division as multiplication. If you have n divided by 4, which is what this is saying, or c divided by 4, whatever you want to use, this is the same as taking 1/4 of n. Right? Taking half of something is the same as divided by 2. A third of something, same as divided by 3. A fourth of something, same as divided by 4. And so now you get that true coefficient of 1/4. But if you want to write it as just n divided by 4, that's fine too. Okay? So these 2 questions due tomorrow. Work must be shown. Okay? Show all of your work. Write the expression. Solve each question. Each one has more than 1 question to it, right? So you're testing something. And this is due for tomorrow. Zoe. Well, what are you doing? You are going to the store. You're buying cards as a group. You're dividing them evenly among the 4 of you. And then the additional 30 that you have from your parents, that's going to equal the total number of cards in your collection. Okay? All right. That's how I am.
Don't forget to like.
Thank you.